it looks like it might be a partial fractions problem because the bottom can be factored. But the problem here is that the top has a bigger degree than the bottom. So before we do partial fractions, dividing takes precedence. So before we're going to do anything else, what we're going to do is we're going to do long division here. Okay? And we can't do synthetic division because we have an x squared. I'm going to go ahead and put in a 0x squared. We might not need it, but I'm going to go ahead and put it in anyway. Okay, I start off by trying to figure out what do I multiply x squared by that will give me x to the third. That's an x. And then I multiply it out. So x to the third plus x squared minus 2x. You subtract. So basically all of those, I can change it. That goes away. This is negative x squared. This is negative and ends up being plus there, so just plus x, and then bring down the next thing. Alright, x squared times what is negative x squared? Negative 1. And then multiply it all by negative 1. So I multiplied negative 1 times each thing. I'm going to subtract, which means change those signs again. So that's 2x plus 1. And what that does is that tells me that this integral is the same as x minus 1 and then plus our remainder, which is 2x plus 1, over whatever we were dividing by. And we get that. The x minus 1, we can find that antiderivative, and we can do that closer to the end of the problem. But the part that's important is this part right here, and this is the part we want to do partial fractions on. Okay? So the next thing we're going to do is to factor that bottom. And we're going to come back to that first part, but for now we're really just focused on this part right here. That would be x plus 2x minus 1. So we'll have a over x plus 2 plus b over x minus 1 equals what you started with over all the stuff. And this part I feel like you can do. The part I really wanted you to see was that dividing. But basically I'm going to multiply the a by the x minus 1, so ax minus a. B multiplies by the x plus 2, and that equals the top. Okay, everything with x goes together, so a plus b equals 2. And then the negative a plus 2b equals 1. And at that point, you can solve it however you want to. Again, I've told you before I kind of like elimination, but if you like substitution and would rather do that, that's fine. What I would do is probably put this one underneath here. And with elimination, I can go ahead and add because that will cancel out. I get 3b equals 3, which means b is 1. And you can plug that 1 back into either equation, and you'll find out that a is also 1. Okay, so we go back to the beginning, and really we had the x minus the 1, and then we had 1 over x plus 2 plus 1 over x minus 1, and then the antiderivative here would be x squared over 2 minus x, natural log of x plus 2, and then natural log of x minus 1. Okay, so number 11 is still a partial fraction problem. We do not have to divide because the top is still a smaller degree than the bottom, so that's good. Let's go ahead and factor and see what is different about this problem. So you can factor out an x squared and you get an x plus 1. Anytime you have a term that is squared, you have to do something a little different. And the reason is because there's lots of possibilities of how the fractions could have been set up to get that whenever you add it together. Okay? It could have been an x squared and then an x plus 1. Or it could have been an x and an x squared and an x plus 1. All of those still have the same common denominator. Okay? So what you do is you make one thing just be a over x. You make another thing called b be b over x squared, because that's a possibility whenever you work it out that that could have been part of it. And then the third one is the c over the x plus 1. And this happens anytime that you have something squared like that x squared right there. If you have x plus 1 squared, you're still going to have x plus 1 here and then an x plus 1 squared there, because that's a possibility. Now, it could be that a comes out to be 0, and that is a possibility as well. But you have to work it out completely because we don't really know what it would have looked like. Okay? Now, the process from there is the same. It's just the way that we needed to set it up. So, once I try to figure out, okay, my common denominator here is going to be the x squared and the x plus 1. So what I'm missing is an x and an x plus 1 for the a. So I'm going to multiply by a by x squared plus x. For the b, the x squared's here. That x is there. That's okay. I don't need to put another x because it's part of the x squared. X plus 1 is the only thing missing. And then for the x plus 1, the x squared is missing. And that x, again, is part of it, so I don't have to do like x cubed or anything like that. So I get ax squared plus ax plus bx plus b times 1 plus cx squared equals 4x squared plus 2x minus 1. Alright, so let's see what all we have here. So we have a plus c equals 4. We have a plus b equals 2. And then, very nice, at the end we have b equals negative 1. Now that we know b, we can plug it into this one. And I always just look to see what would be easiest next. B is negative 1, so I can plug it in there and I can get a. And then once I know a, I can plug it in there. Subtract 1 and get c. So we have the integral of 3 over x minus 1 over x squared plus 1 over x plus 1. Now the antiderivative is just a tad bit tricky because you do need to think about that this is not natural log for the antiderivative. These two are. This is just 3 natural log of x, and this is 1 natural log of x plus 1. But for this one, because that's raised to a second power, I have to just think about the antiderivative rules. Think that this is x to the negative 2, so I'm adding 1 to it and dividing by it. So that's just 1 over x, or x to the negative 1. Now 12 is going to be done very similarly. I'm not going to complete it all right here, but I want to show you the process of setting it up. See, again, it's something squared. And it seems like in our mind, why can't we just do a over x minus 2 and b over x minus 2? But it doesn't work that way because there's lots of more possibilities it could be. And so the way you set this one up is to do a over x minus 2 and then b over x minus 2 squared. Anytime you have a squared term, you do a over one thing and b over the squared term. If it was cubed, you would actually do three things. Okay? Alright, I'm going to pause it there and let you finish that one. Okay, here's another weird case with partial fractions. You don't want to divide because the top is a less degree than the bottom. I want to go ahead and factor out the bottom, which the only thing I can do is factor out an x. And so I get something like that. And really that's not a lot different from what we've looked at, but when we set up the question to solve it, what you have to do is you're going to have a over x, and we know there's going to be something over x squared plus 7x squared plus 1. And we want this to equal 9 minus x squared over all of that. The problem is I can't just put a b right here. And the reason is because we have a squared term. It's not like x squared in parentheses. It's not x minus 2 squared, kind of like the last one that we looked at. But we have something squared. It's called a quadratic. So we have a quadratic that's on the bottom. And if I put a b up there, it's not going to work out for us. Okay? If you have a quadratic term like this, that's not just something in parentheses squared, you have to put a bx plus c. Or it could be ax plus b. It could be whatever letters that you need to use in the problem, depending on how it looks. But when you have a quadratic, basically you have to have a linear up at the top. Okay? Again, solving it is not very much different. It's just a little bit more complicated because that bx plus c is there. So I want to multiply this by 7x squared plus 1. And I want to multiply this by x. So we'll have 7x squared times a plus 1 times a, which is a. X times that, so that's bx squared. And then x times c would be cx. And like I said, not really different. It's just the way that you have to set it up that I wanted to explain. So all of our x squared things are there. So we'll have 7a plus b equals negative 1. And then all of this will, cx, or just c, will equal 0. Because there's not an x term over there. And then a will equal 9. So it comes out really nicely that c is equal to 0. And it's okay for that to happen, but whenever we're setting it up, we have to put it in as if it's not going to happen because we don't know for sure. So this actually came out really nicely because it gave me a, it gave me c, and then to solve for b, I can get that pretty quickly. I can plug the 9 in for a and solve for b. It seems like a really awful number, but it's okay. It works out okay. So that means we have the integral of 9 over x plus negative 64x plus 0, so I don't have to write it, over 7x squared plus 1. Alright, so we want to do the antiderivative here. I know the antiderivative on this part is 9 natural log of x. The question is, what about this awful part? Actually, you can use u substitution, so I'm going to do it to the side because it's not as obvious to me what it's going to be. So u is 7x squared plus 1. du is 14x. And so, as I'm doing this integral here, I'm going to take that negative 64 out. And remember, I always put the 14 in and take 1/14 out. So that means that we've got a negative 64 over 14, because the 64 is out, and plus the 1 over 14. And then natural log of u, because that's 1 over u. And then you can simplify that to negative 32 over 7 if you want to, or you can leave it. So 17 is another weird one that I just want to talk about real quick and set up for you. I do want to factor this, and factoring this is a little different. I still factor it the same way, like find the things that multiply to give me 8, that add to give me negative 2. But instead of these being x's, these are going to be x squareds. 4 and 2 still give me 8. I need to get a negative 2, so that's going to be negative there and positive there. And then I can factor again. I'm not completely done factoring. And so I have this. Now, to set this up, what we would do is we would say a over x minus 2, b over x plus 2, and then this x squared plus 2 part, that's the part that you have to do the something x plus something, because that's a quadratic term. Okay? So there's actually a c and a d on this problem. And then over all that stuff, I'll just put a squiggle for now. So for the a, we were missing these two parts, so I multiplied them together, because I know it's going to be a times that. For the b, I'm missing these two parts, so I'm going to multiply that together. X to the third plus 2x minus 2x squared minus 4. And then the cx plus d, you're missing these two parts, which is x squared minus 4. Alright, so I'm going to go ahead and multiply and get ax to the third plus 2ax plus 2x squared a plus 4a. And that's just a times all that stuff. When I multiply the b times all the stuff, I'm going to put it underneath the one that it goes with. So b goes with x to the third. b2x will go here. b times negative 2x squared will go here. And negative 4b goes there. Okay? Now I'm going to multiply this and put it where it goes. So 6x and x squared goes with the x to the third. 6x and 4 would go here. I say 6, I mean c, sorry. Negative 4cx. dx squared is going to go here. And then negative 4d is going to go there. And that gives us several equations. So it gives us a plus b plus c equals 0, because this is going to equal x squared. There's no x to the third term. 2a plus 2b minus 4c equals 0. 2a, minus 2b plus d equals 1, because that's the one that has the x squared. And then 4a minus 4b minus 4d equals 0. For this, I'm going to pick two equations that have the same letters in them and try to combine them and work them out. Like I'm going to try to see if these two together will give me something, or if these two together will give me something. Okay? And you can do it whichever way you want to. Again, like I've talked about before, I really liked elimination, so I'm probably going to change this one right here. Divide by 2 and get A plus B minus 2C equals 0. And see if I can combine that with this one. And really I need them to be opposite signs to cancel out, so I'm going to change the signs as I write it also. What happens is A and B all go away. And so 3C is 0, so C is 0. All that work for C being 0. Yuck. Okay, let's see what else we can do. Maybe we want to take these two equations because they all have the same A's and B's. Maybe they'll work itself out. So I have 2A minus 2B plus D equals 1. I'm going to divide all that by 2 as well. And I'm going to change those signs. And that's nice because all that goes away. I get 3D equals 1. So D is a third. And I'm just showing you like one way to work it out. There may be other ways to work it out. Okay, so we got C, we got D, we need A and B. This equation is a pretty good equation because if I plug in C, which is 0, that's going to tell me something really important about A and B. That tells me A is negative B, so if I can figure out one of those, that's nice. And then you can plug A and B into some equation where you know D. Maybe that one, because that one looks easier. If A is negative B, that would be negative 4B plus a third equals 1. Subtract a third and divide by negative 4, and you're going to end up with A equaling 1/6. Very quickly, just to tell you what happens after that, because we figured out what A, B, C, and D are, that means that we're finding the integral of, okay, A was 1/6, so 1/6 over x minus 2. B was negative 1/6, so negative 1/6 over x plus 2. C was 0, so then we had 1/3 over x squared plus 2. And then so the final answer is the antiderivative of that. These two will both be natural logs. And then this one comes out to be an arctan. Because of time, we'll stop right there.